Hi, I'm Mike Dooley from Labrador Systems. We're here developing a new generation of assistive robots that are designed to help individuals to live more independently. Now, we're still coming out of stealth mode, so we're not able to show you the full product capabilities in today's session. However, we're going to give you an exclusive preview to some of the key capabilities of our platform. In particular, we're going to talk about how we integrate robotics, voice, and the cloud all together to let you literally push atoms with your voice. And this is a really important feature, opens up a lot of new possibilities. But this camera's in a weird spot. I'm sorry for can we take a quick break here and let me, what's the best way to adjust this? Alexa, ask Lab 1 to raise the camera.
Okay, raising the camera now.
This is much better. Sorry for that interruption. I'm going off tangent. Where was I? Yeah, we were talking about using your voice to push atoms, which is actually what I just did. So no, we're not working on a robotic selfie stick. It's a much bigger idea than that. Actually, what I'm looking at right now is one of the pilot robots that will soon be testing in senior living communities. What I can say is that we have a platform that can move things in multiple dimensions, and most critically, bring things within reach of individuals that need them. So to kick things off, why don't we give our friendly test robot here another command and show a little bit about our test environment here. Alexa, ask Lab 1 to go to the entrance.
Okay, going to the entrance now.
So what you're actually seeing here is our test setting. This is designed to mimic a number of different types of settings, anything from the home to senior living facilities or a hospital. And we use this to test operating the robot in different real-world conditions before we roll it out like we will be doing into senior living facilities. And in doing this, we're going to be using a lot of different systems combined with going on the edge with what the robot's able to do here, as well as systems like Alexa, as you saw, and things in the cloud to sort of make the whole piece work together. So really excited to jump right into the presentation and get into some more of the details. So hi again, Mike Dooley. I'm CEO of Labrador Systems, and this is the presentation section of our session. I'm going to be joined with Philip Case, who's our senior robotics engineer, to go into more of the technical detail. But first I'm going to start with sort of an overview of the concept and provide you a preview we haven't shown people before. So we're really excited to debut some of these things. Again, this topic is pushing atoms with our voice, and what we're doing is developing a new platform that brings things physically within reach of folks. And we focus a lot on individuals who have mobility impairment, so they're using a walker, wheelchair, or cane, or may have difficulty carrying something because of arthritis or some other limitation, but also the people that care for them. And so what that does is that puts us in a couple of different scenarios. It puts us in the home where a lot of people want to stay and age in place. It also puts us into senior living communities where people who need greater assistance or just need that extra support live and get care there. And we can even go into hospitals and other settings. So we have a pretty broad charter, and it takes a lot of robust applications to make all that work. A quick outline of what we're going to cover. We'll give you a really brief background about Labrador and the team, because we've been doing robotics for a while, and we're really excited about everything that's happening now. It's really interesting time to live in this era. Give you a preview of the development and some of the sample use case scenarios. And we'll jump a bit into like what's different about our technology strategy, where we really charted a different course that we went off here. And then we're going to go into an overview of the tools and architecture. Philip's going to cover that. And then we should have plenty of time for Q&A. So please write down your questions or put them in the chat so that we can address those. And we're happy to share as much as we can, and it's probably more than you probably think. So let's jump into it. So first thing about the background. So I'll just, fair warning, I'm old school. So I've been in robotics for over 20 years. And my partner has been in robotics and automation for almost as much time. So we founded this company back in 2017, but I started in robotics back in 1997. And the first product I worked on, you might know about, is Lego Mindstorms. I was both the product and the marketing manager on the Skunkworks team when Mindstorms was just a little project at Lego that was supposed to sell a small number of units. I think 10 to 15,000 was my charter when we did that to users in home. And instead it went on to, that SKU went on to sell over 1 million. And I think it's still today the best selling product in the history of Lego. That got me really excited about robotics. And when I talk to a lot of CEOs and VCs and engineers and PhDs today that are now in their 30s or late 20s and sometimes early 40s, that got them excited about robotics too. I'm older than all that. And so it really opened up this new possibility. And from there, we moved on to from toys and educational products to work on home applications and taking it to the next level. That led us to Evolution Robotics, where I met Philip and also Nikolai Romanov, my co-founder and CTO. And we worked on a number of technologies that were all about taking aerospace grade technologies and bringing them down to consumer prices. And the combination of that was both a product and a technology. The technology was Northstar, and Northstar was a IR-based sort of indoor GPS system. It was one of the first low-cost localization systems that you could use to allow a product in the home to track its position. And what we did with that was Mint, and Mint was a robotic mop, and it would take Swiffer cloths or microfiber cloths and systematically clean the floors, wet mop them, go around the edges. It would figure out if the dog was sitting someplace and came back and it was there, so it wasn't there anymore, so it would clean and open everything up, and literally could cover a full room, and ultimately later on a full, almost like 1,500 square feet, all tracking its position where it was cleaning. We launched that as a product, took it all the way to market in 2010, and we got acquired by iRobot, the folks that were making Roomba. And Roomba at the time was still, it was called adaptive random. So basically it had intelligence about how the algorithms would work to fill in a space, but it wasn't tracking its position in sort of a global position sense that most people think about today. And so a number of things happened because of that. One is Mint became Brava, and it's still on the market today. It's in its third product now, and you can actually see some of the products that we've worked on still on the market as well. So Mint became Brava, and became a good second product in the portfolio after Roomba. And then what also happened is the technology that was at Evolution, both some of the navigation algorithms that were used for coverage patterns in Mint, as well as our next-gen recognition and tracking systems, which is called vSLAM, really one of the first visual SLAM systems out there commercially. All that got fused together with all the code and the development at Roomba. And in 2015, you had the Roomba 980 launch, and it had iAdapt 2.0, which was a fusion of all the iRobot technology with a lot of the key sort of new parts from Evolution, and that's what created Roomba, which now systematically maps and cleans as it goes. And iRobot's gone on far beyond that, and now lets you sort of set rooms and schedules and virtual boundaries and track its position. So what I think about robotics, a lot of times I'm not just thinking about the moment in time that we're doing something. We're thinking about what's sort of the big next step that we're enabling. That Mint was really a vehicle to sort of prove that low-cost systematic navigation could be done. It was sold at Bed Bath & Beyond in 2010 for $199 US dollars retail, and you still could use your 20% off coupon on top of that. So super, super low cost, but it sort of demonstrated that what you could achieve. And then that DNA fused with a much larger company, iRobot, to proliferate their product line and then move on to new things. So we get really excited about this idea, like Mindstorms was as well. It's just a simple idea, probably pretty complicated technology at the time, but then 5 years, 10 years, 20 years later yields big results. Well, that's what we're working on right now. In terms of the mission here is we're worried that we don't take good enough care of seniors. We really don't. And it's not for lack of trying or for the people that are in the industry. They do a wonderful job, and there's just not enough of them, and it's too expensive to deliver the care that we need. And we have too many seniors coming into the system as well. And so what we're worried about is how can we make robotics be very pragmatic and do meaningful things today and make a difference for my mom who's still around and about to turn the corner at 90. But what's our life going to be like 20, 30 years from now or 40 years from now? So this is a really key mission for us. And so we take this really seriously and are trying to do it all right. We're trying to get the technology right, the cost right, and the user experience all connected together. So let's jump ahead into that. And this is where we're going to give you some information that we haven't shared before as tightly as this. So here's a little bit of an unveil. So what are we doing? Just some key points. we're pioneering this new generation of assistive robots to help people live more independently. Again, we're performing practical physical tasks. We're not a social robot. It's not that social robots are bad, but we are setting out to sort of get value because we physically do something for someone. And my big payout, like the first robot prototypes are pretty ugly. They're all engineering units, and we brought them into people's rooms, and within a minute they asked they can name them. And that the fact that they want to put like anthropomorphize this platform that's more engineering and plastic and metal than it is decoration or looking like a character really speaks to, I think we're on to something that does something meaningful to them. And we're going to get into that and more. As I said before, is that we focus where we have a impediment to mobility, and that starts off, the most obvious case is someone who starts using a walker or cane as they're aging, or may have could have a semi-temporary injury that could be going on for 6 months if you've had a skiing accident or others. When people see this while working and go, man, I really could have used that when I was recovering, or my mom or dad could really use that where they are right now. So our goal is to meet people when they start to have these issues and provide this extra pair of hands. And then as people progress, to be able to provide more support, grow with their needs, and also support the caregivers who just do a tireless job of helping people. And in this time with COVID, it's taken on a new meaning, because where it used to be that someone who was, let's say, in a walker who just went to bed, is tired, but they forgot to take their medicine or forgot to get a drink of water, now they're sort of scared about falling, or it's going to be trouble for them to get up, go in the dark, turn on the lights, get over and get a glass of water and take their pills, which was a scenario that we just have the robot come and bring to them. There's now another type of barrier around distance, and that's COVID. And so in a senior living facility where you're either you're potentially isolating sometimes people that don't have the infection, but you're trying to protect them from the possibility of contact with those who do. And all of a sudden there's a gap. That person who is delivering that, that morning hydration cart, the drink and their ice and all those things, or the afternoon snack, now has to gear up in PPE, take the time, scrub down, take something in, be really careful about contact, and get out. And instead, could we use robots not to replace the caregiving side, not to all the other things that are really critical about helping people transition, bathe, get dressed, and in personal care, but some of these other items that are becoming a greater burden now that we have an extra stressor like COVID-19 in the system. So we have a broad charter. We operate in homes and group care facilities. And in that space that I was looking at, that's actually what we model. We literally put in sort of temporary walls and move the furniture around to simulate a different environment. Again, we support individuals and caregivers. And then a key thing we're going to talk about is that we build upon consumer electronic technologies to make the platform much more affordable and scalable. This is key, and it gets really missed when we talk to certain investors or people on the market, is that the reason why Roomba can navigate today isn't because of some great technology that was developed, for warehousing. It was because of the iPhone and mobile phones basically driving the cost of cameras, gyros, processors, all that stuff we steal in robotics over to make that make it really affordable, and then we take the software and make it all work. We're doing the same with a new generation of technologies, and I'll be getting to that in a little bit. So let's jump into the world. This is the people we face, and pretty shortly are going to be going back into that environment to some of our partners in senior living communities. Currently, so if you have a parent or if you're living in a senior living community, chances are you've got this pendant. You have what's in that, what the woman is wearing with the heart on there. And that pendant is your emergency call button. Sometimes it has fall detection or other functions built in. But if you're not feeling well, if you need help immediately, you're supposed to hit that button. And sometimes it's a watch or it's around your neck, but it's really common to see those. And so when we went into folks and we said, well, how do you get stuff that's not critical? How do you, let's say you're cold and you need a blanket, or how do you call down for, for an extra drink, or whatever you might need during the day there. And they go, oh, we just click on the pendant. And I'm going, I thought that was your emergency pendant. And I go, yeah, but we just click on that, they'll come too. And this was not an isolated case. This was actually multiple locations that we went to. Was the same story. And the issue, and I would say, well, how long would it take them to to basically come and respond. And it'd be, oh, it could be 10 minutes, 30 minutes, sometimes an hour and a half if they're really busy. Sometimes, they're busy in the morning or in the afternoon. And what was happening is that, this is what the shock to our system was. I saw it when my mom was receiving home care, and I saw it when we went into senior living facilities, is that just the technology isn't being deployed, developed, and all the way brought to the last mile to sort of do things that are pretty simple in other cases. So basically being able to sort of say something to Alexa and ask for something instead, rather than say, hey, can I have a blanket? And that goes in a queue or something, as opposed to this, like, you're messing up the system because that's your emergency call button. And it really frustrates the staff, and it's a problem. But I think it speaks to how far off and how much we really have to catch up and really have to invest in developing these technologies for seniors. So here's a simple example. Let's say that woman is in her residence, and what we could have is a mobile platform like I was showing in the video before, and that platform could have bus stops, and the bus stops are the places it goes. And so robotics, we call them waypoints. When we talk to others in the world, they like bus stops are better. And it could have bus routes, and bus routes are the way it sort of knows how to go around and maybe avoid the china cabinet or where you might want to leave your stuff all the time. And it becomes predictable. And we found when we were working both at Evolution and iRobot, people like predictability with robots. So just think of a platform that can move things and go to reliable positions based on your command. Now, that could be that, let's say the woman is sleeping over at bus stop 3 and she wakes up and she needs something. And so rather than calling the staff, she could sort of say, hey, can I have a drink of water? And the robot might have a little station where it could bring drinks, snacks, medication, other items to the person. And what you've done is immediately solved her issue because she's got it right there, or the robot can even park and hang out by her when she's sleeping at night, and save the staff of that call, and also reduce that burden on the real urgent issues that actually require physical attention. So that's just one example, but you can basically see what comes out of the requirement here is a robot can navigate an environment that can move. People can move their furniture, tight spaces. When I was talking to some investors, you should go to assisted living places. They're all cookie cutter, exact same layout. I see the brochures. And what's funny is that they're not. The layout sometimes can be the same on the room, but think of assisted living as like the smallest apartment you've ever had since you were after college, with the largest furniture you've ever stuffed in there, because people are grabbing like I still can get that sectional in there, and they put carpets and area rugs, and so it's a wonderful, challenging environment for robotics, but we're making it work, but it's really different than a lot of people expect. But that's one scenario that we can do. That also could be at a home, where a person doesn't have access to a caregiver who's around the corner or down the elevator at the nursing staff, someone that maybe their family member is only checking with them, certain times a day, or they have caregivers coming. So what we start doing is this sort of idea of a robot that's dedicated for personal use, and that requires a very low cost to make it affordable. So this is an example that we've actually been researching with COVID applications, is that, again, this scenario that if you're in a facility, you could be under room isolation. A majority of places are where you're restricted to your room out of your own protection. And it's to sort of make sure that there's enough barrier between the outside risk of infection coming into the facility and spreading. And so a lot of places are basically, they've gone from group dining to delivering the rooms. Every meal has to go up to every room now, and do that. So when that happens, the caregiver is supposed to put on all the PPE gear, the protective gear, go into the room, avoid close contact, put the meal in there, leave it, and then go on to the next room. And this has literally messed up the operations of senior living facilities. What they're having is that we've heard of people having to take the back office staff and literally use them to do the meal delivery, because the caregivers are so overloaded just dealing with their normal task, now having to wear PPE and all the other activities. And this is where you don't have an outbreak. This is just to protect it from an outbreak. So one scenario is, if we go back to this, is that one of those bus stops, like bus stop 2, could be at right by the door. And the robot could come to the door rather than asking the person to come to the door or asking the caregiver to come in. And they basically hit a button or call from their phone or however it works. And the robot comes to that position. They put the tray on the robot, and the robot goes to a location where the person can access the meal. And you've created, again, this physical barrier. It's another way of looking at it. Now, there's another example is that the robot could also operate on the floor. So the robot could be, at near a caregiving station or a nurse station, and instead of all that walking back, like think of all the activity that someone's having to do to go back and forth from place to place. What they're able to do now is cut that. You basically use this robot as their sort of companion and for the caregiver, and sort of take that heavy load and say, okay, take this to room 213. And the sequence that becomes possible now is that let's say this is a facility that has is equipped with Alexa, and this actually really exists. There's another Alexa phone company called Ava Health that literally is putting Echo Dots into rooms, putting them into a special kiosk mode that one lets people control the lights and get the the information on the schedule, but also digitizes the commands that, again, those button pushes into actually cues that go into a care management system with the staff. So they can, someone can say, Alexa, can I get a snack? And then basically the caregiver assigned to that level sees it pop up on the phone, and she gets a message. And this currently happens right now. Gets a message to say, hey, John is requesting a snack, and she can approve that or assign extra things for someone to do and handle that. And the new element that we plug into is, well, you could give it to the robot and literally sort of say, hey, let the robot take it over to John. So, and again, we're not going to all our features. We're sort of holding back on some of that we'll show later when we launch. But a really basic scenario is like, well, the robot just hangs out by the nursing station, let's say where it charges, and then the caregiver puts it on the tray or whatever John asked for, hits a button to say, hey, go off to deliver. The robot goes to room 516 in that case. Alexa tells that it comes up, and then the person can come and take what they need. Now, there's lots of variance on this, but the whole sequence here is a lot is going on. You basically have an environment that the robot can localize and navigate within. You have interfaces where people are dispatched around the location that take something like voice, which back in 2010 was not an option for commanding your floor mop to work, and ask for something translated into an action, either have human in the loop or not human in the loop. We can automate this where the robot can actually retrieve and bring things based on what's being requested. So again, and the mission here is we're not about like reducing that human contact. We're not about taking out the personal aspect of care. What we are about is, wow, that's a lot of walking around to be basically, for doing the morning hydration card, or for just, interacting with people when they forgot something more minor. And what it lets the staff focus on is the more things that a person needs to do, like that high touch bathing, dressing, helping somebody move, making sure they're comfortable, and give each resident more time on those and shift this other stuff more to back-end automation. Okay, so now we're going to jump into the tech strategy, and this part is really crucial because robotics is not this homogeneous set of technologies that one size fits all. It's a lot of heterogeneous solutions that are adapted to their specific need. And one of the big requirements when you're working on a solution is the cost structure of it. It's not just your performance requirements, it's also literally what are you trying to accomplish as you do things within a budget. So I'm going to pull up a slide here that the first of the sort of lots of asterisks here are warnings. First part about it is that this is a oversimplified but over generally accurate picture of how different solutions fit along the price performance curve in robotics. And some are existing and they've been really optimized and they're on their second or third, maybe fourth generation now, and others are emergent. And we're working on one of the emerging categories because we think it fills this sort of vital gap of commercial class robots that can be affordable for personal use. So let's start and just walk through a couple of the segments and then say what we're working on. So in the bottom left, you have the lowest cost solutions for autonomy that are used most commonly in robotic vacuum cleaners. And this is either visual SLAM, like the systems that we were working on at Evolution and at iRobot, or 2D LiDAR that's been super cost reduced to very low resolution, very low cost, and still manages to work to get you basically localization. And they're fused with other things like gyro and odometry to give you good local tracking of position, and then reconnect periodically to give global positioning. So they're not the most robust solutions, but they're cost optimized to the full extent so that they can make it very affordable to buy, let's say, a $400 robotic vacuum cleaner or $500 robotic vacuum cleaner that can systematically map your house and clean and not miss a spot. And as we said, we worked on a couple of key ones of those back in the 2010 and later period. And they are evolving, like what iRobot is doing with vSLAM, and I think they're on iAdapt 3.0 now, is getting more and more sophisticated. But they're also, having worked for they're really focused on that budget. So then we jump to sort of the second half of the slide on the right side, and we see 2D LiDAR. And this has a wide cost range because there's lots of different solutions out there, and they also have one or more LiDAR sensors and other things configured on here. But this is when you normally think about B2B robotics, this is where people use it. They're using 2D LiDAR SLAM to navigate either a warehouse, a grocery store, could be an office facility, a hospital, and these are generally one-to-many robots. These robots are running either 24/7, they're cleaning floors, they're going and picking up items to get packed into a box, or delivering like a whole tray of meals or up to a certain floor in a hospital. And these robots the technology is very mature, and a lot of you are using it for like SLAM and other solutions and integrating it on ROS. And they're commercial grade, they're reliable, and what we see is a big trend is there's a lot of companies there's in all these different segments, and they're proliferating. And that's great for the growth in robotics. We sort of have gotten out of the lab and we've gotten out of the warehouse. But they also, because of the cost structure, those sensors are running, 1,000, 5,000, 10,000. When you add up all the sensors you're putting on there and the correlated computing that you need to do it, that price tag's fairly high. It's you can't put that on a Roomba and make that ship and sellable and be profitable. Where those prices are having to be sub 100 or less to work and do what they need to do. And so one of the things that we saw as this opportunity was that the world was going in one direction, where the next level was the really exciting stuff like self-driving or sort of a step in between is last mile delivery. And so what and that's pretty much using everything. People are using cameras, GPS, 3D LiDAR, radar, and then when it all doesn't work, human in the loop to make it all together. And that cost is hard to put together, what the effective unit cost is of that solution. But that's driving even more things. It's driving advances in ROS and other architectures and algorithms. And what we saw when we were looking at this space is saying, well, we can't use anything in the commercial robot side for a personal service robot for the elderly or for people that need assistance. It's still too pricey. And even though it's coming down in price, it's just an order of magnitude off of where we need it to be. We know the stuff that iRobot has, we worked on it, that's not yet to that level. That's cost optimized to do a more narrow mission. And so where we did see this really exciting area is this area of AR SLAM, or augmented reality SLAM. And what's happening there is the tracking systems that are being used for your AR headsets, for your iPhones, for visual positioning systems. Basically, if you're playing Pokemon Go and you have Pokemon that's on a park bench and it jumps up and everything's synced and Pokemon's superimposed on that bench, and you track with the camera and everything looks real. That system, basically our ability to move fake things in the real world so that they look real, you hook that with some sensors and motors and some good software on the back end, you can actually use it to move real things in the real world in a very rich way. So what we're doing is we're taking the algorithms, the hardware like depth cameras that we'll get into in more detail, and all these things that are running on lower and lower cost processors, things that we don't have to write our own software for, that we can actually use and adapt and make the robot that you saw in the video. The robot's navigating based on an off-the-shelf set of sensors, running on a relatively low-cost Linux board, on using, as Philip will get into it, stacks of ROS and other elements that we didn't have to build and invent, plus our proprietary code, which is sort of that layer of application that we're creating. So this literally puts us basically in the space of commercial grade performance, but at, we hope, 1/10 the cost of what those robots are tracking at. The other part of that is once you do that, once your component costs are that low, then your volume can go up, which in turn drives your price. So one of the sort of catch-22s in sort of the 2D LiDAR space is when folks go in there, they can prototype fast, they can build, they can take on a segment, but because they're expensive, they're still charging a lot per robot, and you're lucky if you're making 100 robots or a couple thousand robots a year. Even like 10,000 robots is a lot for that space. Where, Roomba, by public record, makes millions of robots. And so if we could have something that drops in price and go from 10,000 robots to 100,000 robots to 1 million robots, the cost structure of the whole robot drops. And so you get this double benefit. The underlying technology costs less, and also the unit costs drive less because you have so much less overhead. And that's our mission, is to basically make mass producible robots that are there for personal care, that have the capability of commercial systems, but closer to the affordability of consumer products. And we're really excited about that. So with that, I'm going to turn it over to Philip Case, who's going to jump into sort of all what's happening under the hood, and then we'll take Q&A afterwards. Thank you.
Thanks, Mike, and thank you all for joining us today. Hi, I'm Philip, Senior Robotics Engineer here at Labrador Systems. Let me say a few words about my background to introduce myself. I studied robotics at Georgia Tech, and I'm a robot software generalist, meaning that I work on things like sensing, estimation, planning, control, through the manufacturing of robots. I've worked on embedded software that goes on microcontrollers, through Linux and ROS, and up to some cloud services. My career started in 2008 at Evolution Robotics, where I first worked with Mike and Nikolai on some of the first floor cleaning robots that actually knew where they were in your house and went about cleaning in a systematic fashion. I've also worked at Wonder Workshop, where we built edutainment robots that introduced kids to the basics of programming. And now, for the last 2.5 years, I've been at Labrador Systems, where, as Mike mentioned, we're working on a new generation of personal assistive robots. I'd like to talk today a bit how cloud technology and other technological advances have made our lives easier as developers and our products more capable. So I'll show you a comparison of the technology stacks that we used in 2010 as we worked on the first Mint floor cleaning robot, and what we're doing now at Labrador Systems. On the left, you see the tech stack for Mint, and on the right for Labrador. Red boxes here represent components that we had to develop from scratch in-house. Green boxes, things that we could use off the shelf, and yellow boxes, a mix of the two. The big picture here is that there's a lot more green boxes on the right than there are on the left. This is for a combination of reasons. First, technology has really come a long way in the last 10 years. And second, Mint was a more cost-constrained product than what we're working on at Labrador Systems. Sensors have become so much more powerful and more affordable. In 2010, we developed our own indoor GPS-like solution for Mint. While today, we're able to use amazing depth cameras and advances in SLAM to get far better information about where the robot is in the house and the structure of the environment around it. Mint used a custom mobility board that was using a very small ARM microcontroller to run the entire robot software system. Today, tablet and set-top box class processors, while not as affordable as what we used on Mint, don't represent nearly the step up in cost that they did 10 years ago. And they bring a host of benefits of being able to reuse existing functionality of Linux, ROS, and so much more. Also, we now are able to easily connect the robot to cloud services, which has allowed us to develop much more robust tools to aid in the QA and development process. Things like simulation, analytics, remote control, and the ability to log into the robot remotely and inspect its state while it's running have made a huge difference. In 2010, our QA process revolved pretty much entirely around log files that were recorded to an SD card, and you had to go to the robot, remove the SD card, get the files, send them to the right person in order to have them inspect what went on and why a problem occurred. Today, with just a few days of development work, we are able to record log files and send them immediately to the cloud, where the right person can be notified so they can analyze what happened and make improvements. So I'll show you a few examples of tools that we are using in our development process. First, we've connected our robot to Slack. This allows us to check and see what the robot has been doing, send it commands, get notifications when something goes wrong, and even get a link to a log file of what was going on when the failure occurred, so we can review and make improvements. Next, I'll show a video made from a log file of our robot operating in a home environment. This, to me, represents how rich the sensor data we're now getting, as well as how amazing these log files are, and how great the tools are for visualizing what's going on in the log files. It's great to be able to use pre-existing tools rather than having to build this thing from scratch. In 2010, our log files were in a format that we created ourselves. The tools to visualize what was going in those log files was all created from scratch in-house. This is just such a vast improvement from what we were doing back then. Here's an example of what we can easily do now with analytics on our robot. With just a few days' work, we were able to start generating analytic events and sending them to the cloud. We can use that information to generate graphs and dashboards that give us awesome insights into what's going on with our robots. What you see here is a histogram of how long it took the robot to navigate along a particular route. We can use this to tell if it took an unusually long amount of time for the robot to navigate and investigate what may be the cause, or to look and see if changes that we've made have had a positive or negative impact on the time that it's taking the robot to navigate. In 2010, this would have required a very observant person watching the robot and reporting back to the team when they noticed something had changed.
Okay, well, that caps up the presentation part. And we first just really want to thank you for taking the time to listen to everything we had to say. And hopefully you found different parts of it interesting on both the tech and the business and the market side. We want to move on to the Q&A section now. And first, just feel really open to ask questions. We'll tell you if we can't answer them, but we're actually unveiling more than we've ever done before here. So we'll see what we can share. And it may be something that's pretty non-competitive for us to tell that you might find interesting. So really excited again to be part of the summit. And Philip and I are going to switch over and take live Q&A at this point. Thank you.